In this example, a mug is pushed with an initial velocity horizontally from the counter with a height of 1.22 meters. As the mug slides off the counter, it strikes the ground 1.4 meters away from the base of the counter. Now, what is the initial velocity of the mug, and what is going to be the final velocity just before hitting the ground? As the mug is pushed horizontally, it means the initial angle of projection is 0, and in this case V0 x is equal to V0. The mug goes down with parabolic trajectory, and then further down and down where the velocity is increasing. Now its final parabolic path, the mug reaches the final stage, and its velocity is the highest because it's just before hitting the ground, and the distance of the mug at this moment is 1.4 meters away from the base as the figure shown. To find the initial velocity, we have the only equation we have along the x-axis, that is delta x equal V0 x times t. Here we have V0 x equal V0, as I said in the beginning. Then all what we want to do, we have to divide x by t, where x is 1.4 and t is unknown. So to get V0, we need to find t in this case. To do that, we have to use the y motion. The y equations we are going to use is delta y equal V0 y t minus half gt squared. Obviously, when theta naught is equal 0 at the beginning, this means that V0 y equals 0 because V0 y equals V0 sine theta naught. And sine 0 is 0. That's why V0 y is going to be 0. So here we have delta y equals minus gt squared, and then delta y, as we know, the mug is going downward with an altitude of 1.22 meters. If we put that into the equation with a minus sign, and we have here minus 10 over 2, that's minus 5 meters per second squared multiplied by t squared. Then from here we can get t, which is the time of flight, it's just 0.5 second. If we substitute this t here, because the time at the x-axis is the same as that on the y-axis, if we substitute it into here, and then we will get this much, 2.86. That is the initial velocity of the magnitude of the initial velocity of the mug. Now, to find the velocity of the mug just before hitting the ground, we use the kinematic equation Vy squared, the final velocity component of the velocity squared, equal to the initial velocity of along the y-axis squared minus 2g delta y. By knowing that V0 y equals 0 and delta y equal minus 1.22, if we put all this information into the above equation, we're going to get an answer of plus minus 4.9 meters per second, and we'll choose the negative sign because the mug is heading downward.